হ্যালো স্যার।
হ্যাঁ, বলো।
স্যার কালকে সিটি আছে তো, তো আপনি কি একটু বলে দিতে পারবেন যে লাইক কটা কোয়েশ্চেন আছে? তাহলে একটু মেন্টালি প্রিপেয়ার থাকতে পারবো।
সিটি বাজাতে
মানে স্পিড।
কত কোশ্চেন লাগে নাকি?
হ্যাঁ, না না, সিটি মানে
সিটি
ক্লাস
বাজাতে
টেস্ট।
কোশ্চেন লাগে? ও আচ্ছা আচ্ছা। আমরা কি কালকে বোধ হয় সিটি তোমার দেবে।
না
এটা ঠিক খেয়াল নেই, তবে 30 নম্বরের কোশ্চেন, যা কোশ্চেন থাকবে অ্যারাউন্ড ম্যাক্সিমাম 40 মিনিট সময় লাগার কথা অ্যান্সার করতে।
আচ্ছা স্যার, মানে খুব একটা লেন্দি
তো সেই জায়গায়
না
তোমাদের এক
তো?
ঘন্টা সময় লাগবে।
ওটাই।
না,
হ্যাঁ
লেন্দি একদমই না।
হ্যাঁ হ্যাঁ।
বেসিক নলেজ থাকলেই হয়ে যাবে, বাট
আচ্ছা
ফান্ডামেন্টাল নলেজ
হ্যাঁ
থাকা দরকার।
হ্যাঁ হ্যাঁ, সেটা ঠিক আছে। মানে ওই লেন্থের জন্যই একটু জিজ্ঞেস করে নিচ্ছিলাম।
মানে লেন্দি কিছুই নেই।
ঠিক আছে স্যার।
কোশ্চেন নাম্বারটা আমার এক্সাক্ট মনে নেই, অ্যারাউন্ড 1 2 3 4 করে তার পার্ট আছে, সেরকম করে আছে। তো টোটাল কটা কোশ্চেন হবে আমি ঠিক খেয়াল নেই।
হ্যাঁ ঠিক আছে স্যার। স্যার আপনি যখন বলেছেন 40 মিনিটের মধ্যে শেষ হয়ে যাবে, তাহলে মানে ঠিক আছে।
হ্যাঁ, আমার করতে খুব
থ্যাংক
বেশি হলে 20 থেকে 25 মিনিট লাগবে, তোমাদের সেই জায়গায় ম্যাক্সিমাম 40 মিনিট লাগার কথা আর কি, যদি পার।
ইউ।
যদি পার
হ্যাঁ।
স্যার ইন কেস কেউ একটু টাইমের পরে দিল তাহলে কি হবে?
সে কি কারণে পরে দিল সেটা আমাকে দেখতে হবে। মানে কারোর যদি জেনুইন নেটওয়ার্কের ইস্যু থাকে, সে আমার সঙ্গে কন্ট্যাক্ট করবে আগে।
স্যার অনেক সময় কি হয়, মেল পাঠালে আউটবক্সে রয়ে যায়, তারপর অনেকক্ষণ পরে যায়, ওটা বুঝতে
না,
পারিনি কি জন্য হয়।
সেরকম যদি হয় আমাকে হোয়াটসঅ্যাপে পাঠিয়ে দিও একটা কপি।
স্যার কালকে ওরকম হয়েছে আমার, ওই জন্যই বললাম।
না, সেরকম হলে আমাকে সঙ্গে সঙ্গে হোয়াটসঅ্যাপে একটা কপি পাঠিয়ে দেবে, আমি সেটাও অ্যালাউ করি। কালকেরটা কি তোমাদের অবজেক্টিভ টাইপ ছিল না ডেসক্রিপটিভ?
ডেসক্রিপটিভ ছিল স্যার।
আচ্ছা, কি 1 আওয়ার?
হ্যাঁ স্যার, 1.5 আওয়ার্স।
হুম,
মানে ওপর নিচে ওই 15 15।
হ্যাঁ বুঝেছি। হুম। তো আমি জয়দীপকে যেরকম বলেছি, আমার পরীক্ষা 11টা থেকে শুরু কথা হয়েছে। সো আমি অ্যারাউন্ড 10:55 আমি কোশ্চেন পাঠিয়ে দেবো থ্রু মেল। অ্যাট দ্য সেম টাইম আই উইল হোয়াটসঅ্যাপ দ্যাট কপি টু জয়দীপ। You may take it from that WhatsApp group message, or from my mail, whatever you are comfortable with. And your writing time is from 11 to 12. Within 12:15 you have to send me back by the mail your scanned PDF version. তোমার জাস্ট ছবি তুলে পাঠিয়ে দিও না, সেটা আমি দেখতে অসুবিধা হয়। ওটাকে পিডিএফ এ কনভার্ট করে পাঠাবে। এখন সবই ডক স্ক্যানার বা যে কোনো স্ক্যানারেই কিন্তু ওই পিডিএফ করে দেয়, তো তাতে অসুবিধা কথা নয়। তোমরা অলরেডি কাস্টমড হয়ে গেছে। Savaj, just a few minutes back I answered this question, so please get it from your friends. Okay, good morning. আমি স্টার্ট করছি। So last class, what we have studied is these things probably, if you remember. We went through the basic memory elements. We have seen that we have found the differences between the combination logic and sequential logic. Then we have seen that in the sequential logic block diagram, there are 3 basic units. Two of them are combination logic units, and one is the memory unit. So apart from the memory units, how to design the combination logic units, that we have studied in details. So the leftover portion was the memory unit block. Once we understand how to go for one memory unit, in that case we should be able to go for the designing of sequential logic circuits as well. So for that, in the last class discussing about the memory units available. And we have also mentioned that there are 2 basic memory elements, and they are the fundamental NAND latches and the NOR latches. And we have seen that what type of feedback is used in the this NAND latch and NOR latch. What type of feedback is used?
Positive feedback.
Positive feedback, because the total phase shift encountered in the loop is 360 degree. That is one odd multiple of 2 pi. We have also seen one application of NAND latch as a switch debouncer. Hope you remember. Then we found that in this both NAND latch and NOR latch, when the inputs are changing, their effect may be felt at the output. So there is, I cannot restrict the input at only a particular time instant should affect the output. That is not possible in the fundamental NAND latch and NOR latches. So to enable that, we have to go for the introduction of another signal, that is the clock signal. Now, for that, some modification has to be implemented along with the fundamental NAND latches or the NOR latches. And and we have also mentioned that we'll be mainly concentrating on the domain where we use NAND gates as the basic unit. Rather, the NAND latches are the basic memory units. Similar analysis can be held for the memory units where NOR latches are basically used as the basic memory units. So we'll be only concentrating on the NAND section. But do remember that the similar type of analysis can be done for the NOR latches also, or the NOR based memory elements also. Then we went for the clocked memory elements, and for that we studied the clocked NAND latch, and that clocked NAND latch was termed as the Esr latch. And in that clocked Esr latch or the clocked NAND latch, we found that there are two types of inputs possible. One is called the synchronous inputs, and the other one is called the asynchronous inputs. And we've seen how the asynchronous inputs may affect the output irrespective of the condition of the clock signal. Whereas in the synchronous inputs, when the clock is active, only during that period, the synchronous input will have effect on the output. So that's the fundamental difference between the synchronous and asynchronous inputs. Then probably I cannot exactly remember whether I have discussed about the differences between the latch and flip-flop. Have I discussed about this? The difference between latch and flip-flop?
So latch may or may not have a clock signal, and a flip-flop must always have a clock signal.
Then there was one second vital point. Have I mentioned that?
Uh, the output depends on the clock active level, and for flip-flop, it is edge sensitive with respect to clock.
Exactly. Very good. So I repeat that the basic difference between the latch and flip-flop is, in the case of latch, it may or may not have the clock signal. That means latch may be clocked or it may not have any clock signal at all. Whereas in the case of flip-flop, it must have one clock signal. Second and more fundamental difference is, in the case of latch, in the case of latch with clock signal, there the output responds to the input whenever the clock is active. That means the output is level sensitive with respect to the clock active level. Whereas in the case of flip-flop, the output responds to the input only during the clock active age. So let me go for one, just show the difference. So this is my clock signal. Let's try to follow the way I am drawing. if you follow it and if you memorize it, all types of memory elements can be drawn very easily. What I have done is I have first gone for this fundamental NAND latch. Then we have on the basis of this one, we have extended the other portions. So first you have to draw the cross feedback for the NAND gates in the connected in the cross feedback manner. So that's the starting point. With that, you go on extending it. So this was probably your clocked NAND latch or the Esr latch. Now here, this S and R, they will affect the output only when the clock is
1.
1. That means during this portion. And during this portion of the clock signal, the S and R, even if there is any change in S and R, that will have absolutely no effect on the output. What will happen to the output over that period of time? When the clock is low, what will happen to the output? What happens to Q bar when the clock signal is low?
Previous output
Maintain.
continues.
Maintain.
It will maintain the previous state. Previous Q bar values, whatever the condition was available in Q bar, that will maintain throughout the portion of time when the clock is low. But it is the duration where the clock is high, where S and R are free to affect the output. So that means the output is depending on the synchronous clock, synchronous S and R inputs over the duration where clock is active, and that active state of the clock is logic high state. So here the output is level sensitive with respect to the clock, and here the active level is logic high level. If there was one inverter placed here, then what should be the active state of the clock?
0.
0. So in that case, the memory element will be one low level sensitive memory element with respect to the clock. So the output will be at level sensitive with respect to the clock once again, but here the level which is active for the clock is the low level. Whereas in the previous version, the active high, the clock was active high. In the new version, the clock is active low. That's the only difference. Now, circuit symbol wise, it looks like this. But here, this is one Esr latch where the active level of the clock is high level. If I give a bubble here, that implies this will once again be one Esr latch, but here the active level of the clock is the low level. So this is the basic difference. Okay. Now, have I mentioned about the circuit symbol of the flip-flop?
Yes, sir.
In any case, I'm doing that once again. So that's the circuit symbol of one flip-flop. Here, this arrow basically indicates that here the active state of the clock is not the level, but one particular edge. And as there is no bubble, the active edge is the rising edge. If there is a bubble, that indicates the active age is the falling age or the low going age. But remember, this arrow indicates that this is one age sensitive memory element, and that's why it qualifies for the nomenclature of the flip flop. Then we have seen that there is some problem with the SR latch. What is the problem in the SR latch? What is the problem in the SR latch? What is the difficulty normally a designer faced with the SR latch? SR latch ইউজ করতে গেলে ডিজাইনারকে কি প্রবলেম ফেস করতে হবে?
So we 1-1 prohibited case time.
Yeah.
Esr
in the case of rather the synchronous inputs are here S and R. Now that should be ideally altogether 4 possible input combinations, but out of these 4 possible input combinations, 0 0 0 1 1 0, these 3 are allowed, but the 1 1 input combination is strictly prohibited. So that means the designer is constrained with the difficulties that in the if he uses or if she uses one SR latch, he or she cannot use the 1 1 input combination. But that is one severe constraint. So there is a requirement, there is a genuine requirement of a new memory element, be it one latch, be it one flip flop, I don't know, whatever type of memory element you are going for, but whatever is the type of memory element, let it be, there is a requirement that I must allow the 1 1 input combination also. So for that, the designers have gone for a new memory element, and they have termed it as one JK memory element. Let us start with the SR latch itself. And by the way, I have definitely mentioned that the more easier versions of the memory elements are the latches. Design wise, flip-flop designs are very much complicated. They involve very complicated types of feedback inside the design. So if you go for one JK flip-flop structure or the SR flip-flop structure in the manual, you will be really lost. There is a very complex internal structure there. So that's why in almost every book, they only describe the latch structures, but they then unknowingly mentions that they are the flip-flops. But that concept-wise, that is totally wrong. So just remember that if the memory element from the design, it appears that the output is levels to the clock, that has got to be one latch. It can never be termed as one flip-flop. Now let us start with the JK latch itself. Sorry, SR latch itself. So see the structure. I am starting from this fundamental NAND latch, where there is one cross feedback already there. This is the starting point. Then we extended that to include the clock signal. This was your S, this was your R. But as I mentioned that this SR latch is not serving my purpose always. So I have to modify this particular structure, and to arrive, I have to arrive at a new structure, which allows us to use the 1 1 input combination also. Now, in the fundamental NAND latch, what I have done, we have used two NAND gates and we have implemented cross feedback. Now here, in this Esr latch, you implement that cross feedback once again, but from the final output to the primary input side. So this is one final output, this is another final output. From here, give one cross feedback at this point, and from here, and this new structure is having two different input names, and that is the J and K. One minute, I'll come. Baba, echono. Now let us go for the truth table. In some places, you will find that the new state is being termed as Qn plus 1. In some places, that you will find that the new output state is being termed as a Qn. But in this particular case, the previous state will be termed as Qn, whereas in the other case, where the new output is being termed as a Qn, there the previous output will be termed as a Qn minus 1. So whichever you type of nomenclature you want to give, you may proceed with that one. But you should be using that one uniformly. So when J and K both are 0, what happens to the, by the way, this can be termed as the Esr latch, is it not?
Yes, sir.
This fundamental NAND latch, that is also termed as the Esr latch. I have mentioned it in the previous class, I remember. So in that case, what will be the Esr value if J and K are 0, 0?
1, 1.
1. So in case S bar R bar are 1, 1, so what will happen to Q bar?
Previous output will be maintained.
Yeah. So it will be your Qn. Okay. And remember one thing, I am not discussing about the situation when the output situation when the clock is 0. It is obvious that here there is one latch and the active level of that clock signal is the high level. So whatever truth table I am describing here, we're assuming that the clock is already high. Okay, I am not discussing about the situation when the clock is low, because when the clock is low, output will always be the previous one. Now, in case J is 0, K is 1. So what should I start through? Should I start from through S bar or through R bar?
It's good.
S bar.
S bar, because the J value is 0. So it is guaranteed to be 1. But I am not sure about the condition of R bar. Remember, my clock is 1. So R bar value now depends on the previous Q value. Is it not? The R bar, what should be the new R bar value? That depends on this signal nature or the level. So that is nothing but the previous Q value. Now let us assume certain levels of Q bar. So Q initial value state ki ache dholbe?
0.
0. So Q bar must be 1. So that Q bar was available here. That Q was available here. Okay. So now tell me what should be the value of R bar? What should be the value of R bar?
1.
1. So in case once again we have seen we are seeing that once again S bar R bar values are 1 1. So what will happen to Q bar? What will happen to Q bar? Chiki.
Previous output will be
In
maintained.
case S bar R bar are 1 1. Yeah. So why are you not being able to answer these things? What is for S bar R bar 0 0? What should I write a Q for S bar R bar 0 0?
Not allowed.
Not allowed, sir.
Yeah. For 0 1?
1.
And here it's Q minus. Is it not? So whenever you try to, you are going to analyze any type of memory element, you have to keep in mind the input-output relationship for the fundamental NAND latch, that is the S bar R bar latch. That should be always in front of your eye. Okay. So in case my Q is 0, in that case, if my J is 0, K is 1, what I am finding that S bar R bar both are 1 1. So what will happen to output? What will happen to Q?
Qn plus 1 equal to Qn.
Yeah, Qn plus 1 will be 0. That means it will be maintaining the previous state. Now, you might have given me the other option. You may have said that my my previous Q is 1, so my previous Q bar is 0. So what will happen at that time? So this will be 0, this will be 1. So now what will be the value of R bar?
0.
Will it remain 1? Shunte pelam na.
Sir, 0.
It should be 0. It cannot be 1, it should be 0. But what about the S bar?
1.
Will remain
1. What I am getting at S bar R bar latch input? This is 1 0 input combination. And in case 1 0 is the input combination, what will be the output of the S bar R bar latch?
0.
0. So what we find? If the previous output was 0, after applying 0 1 input, that 0 output is maintained. If previous output was 1, after application of 0 1 input combination, the new output will be 0. So that means irrespective of the previous output state, the new output state will be
0.
0. Okay. Now let me go for the third input combination, 1 0. So through which side should I proceed?
K.
Yeah, yes, sir. So the R bar value is guaranteed to be
1.
1.
1. Now once again, let us assume the initial values of Q bar was 0, 1. So 0 means this is 0. This 1 means this is 1. Okay. Now, what should be the expected value of S bar? What should be the expected value of S bar?
0.
0. So S bar R bar is now 0, 1. So what should be the new Q value? What should be the
1.
new Q value?
1.
1. It cannot remain 0, it should be 1. So this will be naturally going to 0 state. Okay, fine. So what I have found that in case the previous output was 0, after application of 1 0 and after arrival of the clock signal, the new output state will be going to be logic 1 state. Now let us continue with the situation where the previous state was one and this is 0. This Q was initially 1 and naturally Q was initially 0. So now what will happen to S bar and R bar?
1. 1.
Both will be 1. As both are 1, what will happen to the output?
Previous output will be maintained.
Yes. So that means the output previous output was 1, the new output should also be 1. So what we have found that irrespective of the last output condition, whether the last output was 0 or 1 does not matter, the new output state will be logic 1 if J value is 1, K value is 0. So this will be your 1. So up to this point, is there any difference between the Esr latch and this JK latch? Up to this point, is there a difference between the Esr latch and JK latch in terms of the input-output relationship?
No.
So in case of Esr latch also, for the 0 0 input combination, previous output should be maintained. For the 0 1, the output should be, the memory element should be reset, and for 1 0, the memory element should be set. So in JK also the same situation. Now comes the fourth input combination. That is the 1 1 input combination. Let us see what happens there. Let us assume that initially the output was 1. So output was 1. So Q bar was 0. So what happens to S bar R bar? What happens to S bar R bar?
1 0.
1. This is 0. So in case S bar R bar is 1 0, what happens to the output?
0.
Yeah. This will be no longer 1. This will become 0 and this will become 1. Fine. Okay. So that means in case the last output was 1, the new output will be 0. Fine. Now let me go for the other situation. Initial output was 0. So Q bar was 1. So that 0 is coming here. This 1 is coming here. Now what happened to S bar and R bar?
0 1.
This should be 0 and this should be 1. So what will happen to Q bar?
1.
1.
So it won't remain as 0, it should become 1 and it should become 0. So what we are finding is, in case the last output was 0, the new output will be 1. But in case the last output is 1, the new output should be 0. So whatever the last output condition was available, it will be just complemented at the level of the new clock level. So whenever the clock is active, the output is going to toggle. If it is 1, it will toggle to 0. If it was 0, it will toggle back to 1. So that will happen always. So that means here, regarding the output condition, we can say that it will be Qn bar. So in the case of Esr latch, 1-1 input combination was prohibited, but in the case of JK latch, with a certain modification of the Esr latch structure, we can implement or we can use the 1-1 input combination where the output simply toggles. That is, the output simply is complemented. New output is the complemented version of the previous output. So this is called the toggling. The output simply toggles. Okay. Now let me analyze it a little more extensively. Initially, J and K were 0, 1. At this particular time instant, J has made a transition to logic 1 state. And what about the K? Now that remains in the logic 1 state. Now tell me what will be the output condition. Q. Initially, what should be the output?
0.
0. Why?
So JK both are 0.
JK, the input combination for JK is 0, 1. So for the JK 0, 1 input combination, the output, required output has got to be 0. So output was 0. Oh, by the way, here we are a bit wrong in our answer.
Yes, 0. Should
Why?
be
Tell me.
because clock is 0.
Yeah, because clock is 0. So
Yes.
here, if we assume that previously the output was 0, in that case, I'll say that it will maintain that 0 state. That's all. Now, let the seer decide whether the initial output should be taken to be 0 or 1. Any seer?
Sir, 0.
0. Fine.
Sir,
So now, when the clock is active, bolo,
do we need to take a consideration before? Yes, sir. Do we need to take a consideration before assuming before plotting these graphs like q equal to 0 if it's not given
Yeah,
previously?
definitely. Remember one thing: any memory element at the time of power on, it will be achieving one particular state. Whether that is 0 or 1, nobody knows. So at the time of power on, it will attain statistically either 0 or 1. But which state it will attain, nobody knows. Nobody can guarantee that always during the power on, the memory element will be initialized to logic 1 state, or nobody can guarantee that the memory element will be having starting with the logic 0 state at the time of power on. So as there is one cross feedback, this output state will be due to the positive feedback nature, the output state will attain either of the two levels, plus VSAT or minus VSAT. But here we don't have the plus VSAT minus VSAT concept. What we have, the logic 0 and logic 1 concept. So the output will be either logic 1 state or the logic 0 state. And due to the positive feedback nature, that state will be attained almost instantaneously, within very small time. So at the time of power on, output will be arbitrarily set at logic 0 level or logic 1 level. But which state it is going to attain, nobody can say that output will be logic 1 or output will be logic 0. So we have to go for one particular initial guess. That's all. So just like you're tossing a coin. So it may have start with logic 0 state, it may start with logic 1 state. And as initially the clock is 0, so that initial assumption will continue.
Yes, sir.
Now only after the Rajdeep.
Yes, sir.
Rajdeep.
Yes, sir. Yes, sir.
Only after the clock becomes active, then we can definitely say what will be the output condition. Okay. So now, as the clock is active at this particular time instant, I should not give the arrow mark. Rather, the clock is active over this span of time. Okay. Now, over this span of time, whatever is the synchronous input condition, accordingly, the output will have its state. Now, tell me what will happen just after the clock is made high. What will happen to the output? What will happen to the output?
It will still remain
1.
No, ke bolle? 1?
Srami. Parvej.
No. Can 1 hobe baba? What is the input condition? Parvej bolo?
J0 আর K1 আছে তো
তো J0 K1 হলে আউটপুট কি হওয়ার কথা বাবা?
0 হবে।
0. So that 0 will be maintained. And initially যদি তোমরা বলতে যে Q was 1, that means initially যদি বলতে this is the condition, and then at this time it will make a logic 0 transition. Okay. So that will be the difference between the assumption of initial Q value to be 0 and initial Q value to be 1. Okay. So we are going back to our initial assumption that Q was initially 0. So that 0 state will be maintained. How long? How long that will be maintained?
Until J toggles.
Until? Yeah. J toggles to logic 1 state, or J makes a transition to the logic 1 state. Now what is the input pattern?
1 1.
1 1. As 1 1 is the input pattern, what will happen to the output?
Toggles. Means it
Toggles.
becomes
That
1
means it will, what will the output state?
1.
1. So output should make a transition to logic 1 state. Is it not? Okay. Output will be logic 1. So let us go back to the circuit. One. This was initially, output was initially 0. So this was initial 1. So that 0 was coming here. This one was coming here. This 0 was coming here. This one was coming here. Okay. And clock is definitely 1. So this will be S bar will be 0. R bar will be 1. So S bar R bar is 0 1. So what will happen to the output? Output cannot remain at the 0 1 state. It should toggle to logic 1 and logic 0 state. Is it not? S bar R bar 0 1 means what will be happening to the output? Q. Q should be
1.
1. So that's what I have seen here. So what is the implication? So this 0 has transited to 1 and this 1 has transited to 0. So this will be no longer 0, this will be 1. This will be no longer 1, this will be 0. This one will make it 1. This 0 will ensure that this is no longer 1, this is 0. So now what will happen to S bar R bar?
1 0.
1 0. Why I am assuming that the S bar R bar is changing to from 0 to 1 and 1 to 0? Because I am still considering my clock is active. I have not ensured that the clock is 0. Clock is still active. That is, clock is still at logic 1 state. So these two NAND gates are still enabled. So S bar R bar are free to change their state if the corresponding NAND gate inputs changes. NAND gate input will change. In that case, the corresponding NAND output, that is the S bar R bar, will also change. Now here, after this point of time, what I find is the clock inactive.
No, sir.
Just after this point of time, is the clock inactive?
Still active, sir.
It's still active. So output has made a transition to logic 1. Logic 1. But the input clock is still active. So that's what has happened here. My S bar has made a transition to logic 1 state and R bar has made a transition to logic 0 state. Now what will happen to Q bar? As R bar is 0, what will happen to Q bar? As R bar is 0, what will happen to Q bar?
1.
1.
1. This will be 1. So as this is 1, this cannot remain at 0. This should also be 1. As this is 1 and S bar is also 1, so what will happen to Q?
0.
0. So that 0 will come here. That 1 will come here. Okay. So output has made a transition to logic 0 state. Now what will happen to S bar R bar?
0 1.
So S bar is 0, R bar is 1. So what will happen to Q bar?
1 0.
0. So that means what I find is the output goes on toggling, or the output races between the logic 0 and logic 1 states. How long? কতক্ষণ পর্যন্ত?
Until clock is active.
Until the clock is active.
The clock remains active. So what the duration for which the clock remains active, if my J and K both are 1, the output will go on toggling, or the output will race around between the logic 0 and logic 1 states. And at the time the output has made a transition to logic 0 state, what will be the output condition? Can anybody predict?
No, sir.
No, because this duration depends on the propagation delay between this output to the input and then once again coming to the output. So over this composite gate delays of the network decides what should be the duration over which the output should remain 1 and over which the output should remain 0. That is, this output toggling period is depending on the propagation delay of the individual NAND gates. So let that be delta, that overall delay be delta, net delay. Let the net delay be delta. And if this duration is delta 1, in that case the number of times the output toggles is delta 1 by delta, approximately, isn't it?
Yes, sir.
This duration, that means where the output has where the input are made 1 from that instant to the instant where the clock becomes inactive. If this duration is called delta 1, and if for one toggling the net time required is delta, in that case the number of times the output toggles is nothing but delta 1 by delta, its integer value. Is it not?
Yes, sir. Yes.
Yes, sir.
Okay, so now these propagation delays, they are totally statistical in nature. They are time dependent, environmental condition dependent. So nobody can definitely say about the propagation, net propagation delay. So nobody can predict what is the value of this delta. So as a result, the number of times the output is will toggle, nobody can exactly predict. So what will happen is at the time instant when the clock becomes inactive, so nobody can say whether the output will be 0 or output will be 1. So once again, what we have seen that in the case of Esr latch, the 1-1 input combination was strictly prohibited. But here in this modified version of the Esr latch, where I have made it, converted it into another latch, but with another cross feedback from the final output to the primary input side, and we have termed that new structure as a new latch, which is termed as the JK latch. In that JK latch, I can use the 1-1 input combination where the output is going to toggle. But it also has one very critical problem, which is termed as the race around problem. Now, what is this race around problem? Now, in case in the JK latch, the J and K values are 1-1, and in case the clock width is not very small, in that case, the output will go on toggling over the period where the clock is active. So output will toggle number of times, many times over the duration over which the clock is active. So the output will race around between logic 0 state and logic 1 state throughout the duration over which the clock is active, and simultaneously J and K are both 1. So that's the race around problem of one JK latch. Now, how can we avoid the race around problem?
Make it age sensitive with
Make it
respect.
there's a very simple answer. Just go for one JK flip flop instead of the JK latch. If I go for one JK flip flop, as in the flip flop, the output is responding only at the instant when the clock is active age, when the active age of the clock is available. So, and the age duration is just a momentary duration. So, the output will toggle only once. So, there cannot be any race around problem. So, if I go for the use of JK flip flop, JK flip flop use না করে আর কিভাবে করতে পারি? Another thing what we can do is we can reduce the width of the clock period. The clock active period, if active duration, if we can reduce that clock active duration to a great extent, and the duration should be set in such a manner that it will allow the propagation from input to output only once, not more than once. In that case, that will be sufficient, that width of the clock will be sufficient to forget about the race around problem, or to eliminate the race around problem. So how to implement that? When the clock was 0, what will be the condition of C1?
1.
1.
All the gates, let us assume them to be practical gates. That means they have finite propagation delays. So will the C1 make a transition to 0 as soon as the clock rising age is available?
No.
There will be certain propagation delay. And what will be the delay depending on? The delay depends on the propagation delay of the inverter. If this is the propagation delay of the inverter, so let delta be the propagation delay of the inverter. Okay, fine. Now tell me what will be the nature of clock.
So it will be high
If all
for
the gates are ideal gates, 1 minute. If all the gates are ideal gates means having no propagation delay at all or the zero propagation delay. In that case, what should be the nature of clock? CLK? In case all the gates
always
are
zero.
ideal gates,
So always zero in
Very
case
good.
ideal.
Always zero. Always, yeah. That should be always zero. But now we're assuming all the gates to be having certain propagation delays or practical gates. So, and as this final gate is one AND gate, the output CLK will be 1 only for the duration over which both the inputs are 1. So what I find is over this delta period near the actual rising edge of the Clk signal, I am having a duration over which the both C1 and Clk both are 1. So for that duration, the output will be 1. Then output will be 0 once again. Okay, but remember this CLK signal will itself be a little bit shifted towards right. Why? Why this CLK signal should be a little bit shifted towards right?
স্যার অ্যান্ড গেটের ওটা একটু ডিলে থাকবে স্যার।
Yeah, for the delay encountered by the AND gate. Final যে AND gate রয়েছে তার তো একটা proportional delay রয়েছে. If that is delta 2, in that case this CLK signal itself, but the nature of the CLK signal will remain the same. This one itself. But only thing is that will be shifted towards right or the delayed by amount of delta 2, and that delta 2 is the propagation delay of the final AND gate. ওকে, এটা কিন্তু জাস্ট এই প্রবলেমটা দিয়ে কিন্তু তোমাদের ওই কিছু কিছু টিআই বা ওই ধরনের আইসি ডিজাইন কোম্পানিতে কিন্তু ছোট ছোট প্রবলেম দেয়। এরকম সার্কিট দিয়ে দিল, প্রপাগেশন ডিলে গুলো বলে দিল, ইনপুট নেচার দিয়েছে, আউটপুট নেচারটা ক্রিয়েট করতে হবে, কতক্ষণ পরে গিয়ে আউটপুটের এরকম স্পাইক গুলো পাবে, এগুলো অ্যানালাইসিস করে বের করতে হবে। তো সেক্ষেত্রে
স্যার আমার একটা কোশ্চেন ছিল।
এক মিনিট, সেটা এটা কখনোই ভেবো না যে আমি এটা এইভাবে বলেছি বলেই এটা হচ্ছে। It will be this particular CLK signal drawing is totally wrong. I should not say totally wrong. The shape of the CLK, but actual CLK signal will be little bit shifted towards the right. That means actual CLK signal should be where this is your delta, whereas this is should be your delta 2. This is delta 2. This is delta. হ্যাঁ বলো।
স্যার বলছি যে এখানে ইনভার্টারই হোক বা এই অ্যান্ড গেটেরই হোক স্যার, এখানে তো মানে প্রপাগেশন ডিলে এটা সেটা তো সবসময় তো একই থাকবে না, এটা তো চেঞ্জ হয়ে যাবে তো।
হ্যাঁ হবেই তো, চেঞ্জ হবেই তো। আমি তো হোয়াট এভার ডন ইজ ফর এ পার্টিকুলার টাইম ইনস্ট্যান্ট।
হ্যাঁ স্যার, কিন্তু বলছি যে তাহলে যে সিএলকে সিগন্যালটা বেরোচ্ছে সেটাও তো মানে সব মানে একই রকম, মানে ক্লক সিগন্যাল যেমন হয় যে একই রকমের ইউনিফর্ম, সেরকম তো হবে না। তাহলে এটা সার্কিটে দিলে স্যার মানে
that width and the timing will be having a certain jitter. Certain jitter will be always there. এরকম কাঁপবে, সামান্য কাঁপবে। And the width will not be exactly the width will not be exactly 4.2 nanosecond. If at a particular time instant delta value is 4.2 nanosecond, I cannot say that always the width of this CLK signal on period will be always 4.2 nanosecond. It may be slightly more, it may be slightly less, depending on the propagation delay.
হাই ফ্রিকোয়েন্সি সার্কিটে যখন এগুলো দেবো তখন সে 4.2 ন্যানোসেকেন্ড থেকে যদি 4.8 ন্যানোসেকেন্ড হয়ে যায় তাহলে সেখানে প্রবলেম হবে না কোনো?
So no, don't confuse this with the analog signals, analog circuits. You are using it in a digital circuit. The digital circuits accept signal frequencies in the range of several gigahertz. So there should be absolutely there is no problem with these things. So what I find is depending on the nature of the propagation delay of this inverter, I am getting one particular CLK signal. Wonder what is the difference between the CLOCK and the CLK signal? What is the basic difference?
সে সিএলকে উইচ কম অনেক।
Duty ratio is
The period,
different.
what about the period?
Same.
The period is almost same. And the fundamental difference is the clock on period has been drastically reduced. So now, if I use this particular clock signal, this is yeah. If that CLK signal is fed here, so will the clock remain like this?
No, sir.
That will be something like this. This is the new clock signal, isn't it? And if that particular delta width of the clock on period is sufficient to propagate the effect of one J and K logic 1 to the output, that means that will ensure only one toggling at the output, but not more than one. In that case, that race around problem can be eliminated. So though in the circuit, basically we are using one latch, by some circuit age on period reduction technique, we are as if going for the implementation of some flip-flop response, but I am not mentioning that this is flip-flop. As if using the latch structure, we're trying to achieve one flip-flop response. Response-wise, this should look like one flip-flop response, but structure-wise, it is never near to the flip-flop structure. It is the fundamental structure is basically the latch structure. But with this latch structure, I have gone for one clock signal processing network, and that clock signal processing network is nothing but which one? Yeah, this one. This is the clock signal processing network, and this is termed as the age extractor circuit. There is as if this circuit is extracting the rising age of the clock signal. যদি ফলিং এজটা এক্সট্রাক্ট করার দরকার তো কি করতাম?
ইনভার্টার ইউজ করতাম ক্লক সিগনালে।
কোথায়?
সিএল।
ক্লক হয় সিএলকে এর পরে বা সিএলওসি কে পরে, আইদার এখানে বা এখানে, যে কোনো একটা জায়গায় I will go for the use of another inverter. So that will just go for give one phase inversion, nothing else. Fine, but what is the problem faced here? It is our problem. If I use this age extractor circuit here at this node, still there will be certain problem. What is that problem? Here,
Sir.
the total response depends on the width of the delta. Now, this delta comes from the propagation delay of one inverter. That may not be sufficient to ensure that the input 1 is propagating over two stages of NAND structures. So, দুটো স্টেজের যে NAND স্ট্রাকচার এখানে রয়েছে, for this structure jk inputed the effect of j and k 1 that effect needs to propagate to the final output q1. But before that, if the delta duration is over, in that case I may not get the desired response. So what I may need to have is I have to increase the value of delta, because this delta is basically coming from the propagation delay for a single inverter. So how can we increase the delta duration?
Use more number of logic gates.
Yeah, use more number of logic gates. What type of logic gate can you use?
AND gate.
Yeah.
Buffer.
Can I use one more inverter?
So
Yes,
we can
sir.
use
But
three
can I use
inverters
one more inverter?
instead of one.
Yeah,
No, two.
you cannot use one more inverter. You can use two multiples of two inverters in multiples of two. Extra inverters. That means the total number of inverters should be over. Otherwise, I won't be getting that 1 phase shift between C1 and C0. So either you can use buffers, and you can say that this is also a buffer. একটা AND gate use করো, যার দুটো ইনপুট কে শর্ট করে টাই করে দাও. So that nothing but one buffer. AND gate, OR gate, whatever you can go for. So this way you can increase the delta, duration of delta. But remember another point, this width of this clock signal, the new clock signal now depends on the propagation delays. Now these propagation delays themselves are depending on the time or humidity condition. So they're time dependent. So I cannot be always 100% sure that this delta will be sufficient. So though in some book you will find that these edge extractor circuits are being used to avoid the race around problem, but that is also not a very good solution, because it may fail many times, because the edge extractor will not guarantee the required amount of delta. So this is not very good solution. In many books you will find that they are using RC hyper circuits as the edge extractor. So what you will see is that before the clock signal of the JK or Esr latch, they are using one RC edge extractor high pass filter. Have you used the RC high pass filter? RC network, have you studied in circuit theory?
Yes, sir.
We have studied RC.
So, but definitely, you have studied the low pass and filters and high pass filters of using RC. Have you not?
No, sir.
Have you studied this circuit? Have you studied this circuit or not? Yes or no?
Yes, sir.
Yes. Yes or no?
Yes, sir.
Yes, sir.
What about this one? Yes or no? Yes or no? Have you studied this circuit or no? Have you not studied?
So not like
No, sir. So the difference was not.
Why? What is the impedance of C? So, if I ask you to go for the transfer function, what will be that? V naught by VIS? What is the impedance of one capacitance?
1 by omega c.
1 by j omega c. Is it not? 1 by j omega c.
Yes, sir.
Yes, sir.
And in Laplace domain? In Laplace domain? In Laplace domain, that is 1 by SC. That is S is basically j omega. Truly speaking, S is equal to sigma plus j omega. But in capacitance and inductance, as in the there is no real part, there is only imaginary part. So S is basically j omega. So the impedance of one capacitance in S domain or the Laplace domain is 1 by SC, and that that of one inductance L. What should be the impedance of one L?
It's SL.
Inductance SL. J omega L. So that will be when that is gets converted into the Laplace domain, that should be SL. So what will be the transfer function? V naught by Vi for the first circuit. These are very basic circuits. What is V naught by Vi? Hey Baba.
Sir, R by R plus 1 by S.
Potential R plus 1 by SC. So that is nothing but SRC by 1 plus SRC. এটার ক্ষেত্রে কি হবে?
One by SC by R plus 1 by SC.
Okay. তো এটাই আসছে তো ফাইনালি?
Yes, sir.
Now, out of which this is called high pass filter, this is called low pass filter. Why? তোমরা কি তোমাদের কনসেপ্টে the impedance of C is 1 by omega C. তাই তো? এটাই ছিল তোমাদের কনসেপ্ট, is it not? যেটাকে আমি একটু চেঞ্জ করে বললাম that no, that should be actually 1 by j omega C, and in the Laplace domain that should be 1 by SC. Fine. Now, for high frequencies, omega is very small, isn't it? খুব হাই ফ্রিকোয়েন্সি হলে ওমেগা ভ্যালুটা খুব ছোট হবে, তাই তো?
ইয়েস স্যার।
মাল লাগাবো,
No, sir.
ফ্রিকোয়েন্সি বাড়লে ওমেগা ভ্যালু কমবে?
Sir, বাড়বে।
সরি স্যার।
হ্যাঁ। So for high frequencies, omega is also very large. So that will ensure the impedance of the capacitance to be
Small.
No.
impedance of the capacitance to be very small. So basically this output, this Vi is basically getting distributed in this branch. A part of Vi is getting absorbed here, and the other part is getting reflected across the R. So, and whatever part of Vi is getting reflected at R, that is nothing but your V naught. So basically that potential divider concept আমরা এই ট্রান্সফার ফাংশনে বের করেছিলাম। So net current was Vi by R plus 1 by SC, and that current into R was the V naught value. So from there we got V naught by VIS is equal to R by R plus 1 by SC, or ultimately SRC by 1 plus SR. Now as the input signal frequency is very large, what happens is the impedance of the capacitance is very small, so very small part of Vi will be dissipated across the capacitance, and the major part of Vi will be reflected across the R. So the major portion of the input signal will be available at V naught. Are you getting me?
Yes, sir.
Yes, sir.
Yes, sir.
Go to the other end. Go to the other end. If the input signal frequency is very, very small, in that case, what will happen to the impedance of the capacitance?
It will be very high.
It will be very high. So as that impedance is very high, so the major portion of Vi will be dissipated across the capacitance, and a very small fraction of Vi will be available at the R. So very small part of Vi will be available at V naught. So overall, this particular network, what it is allowing is the high frequency signals it is allowing to move to the output, or and the low frequency signals it is mostly blocking the low frequency signals and not enabling them to go to the output very smoothly. So very small part of the input signal will go to the output if the signal frequency is very small. So basically that means there is some frequency selection between the input and the output. The low frequency signals are not getting reflected to the output, but the high frequency signals are almost freely moving to the output. So this particular network is termed as the one high pass filter. High frequency signal components are passing to the output, are moving to the output. So this is called the high pass filter. Now, can you say that the second structure is one low pass filter? For the high frequency components, what will be impedance of the capacitors?
Low.
Very low. So this impedance is very low. So the major part of Vi will be dissipated where?
Resistor.
Across the resistors. So very small part of Vi will be available at the output. Whereas if the signal frequency is very small, what will be the impedance nature of capacitors? High or low?
High.
Very high. So the very high impedance. So the major part of Vi will be available across the capacitance. So what we can say that the major part of Vi is getting reflected to the output if the signal frequency is low. So high frequency components are not moving to the output freely, but the low frequency components are moving to the output more freely. So this type of network will be termed as the low pass filter. Okay, এই বেসিক ফান্ডামেন্টাল আইডিয়াগুলো কিন্তু দেখো বাবা, এগুলো কিন্তু ফান্ডামেন্টাল আইডিয়া, এগুলো সব জায়গায় কাজে লাগে। যে কোনো গেটের ইন্টারভিউতে যাও বা যে কোনো কোম্পানিতে ইন্টারভিউতে যাও, আই এম নট টকিং অ্যাবাউট দ্য আইটি সেক্টর কোম্পানিজ, আদার কোম্পানিজ, সেখানে কিন্তু এই সার্কিট থিওরির বেসিক নলেজগুলো কিন্তু খুব ইম্পর্টেন্ট। তো সার্কিট থেকে কে পড়াচ্ছেন?
RG ম্যাম,
এই সেমিস্টার আছে না আগের সেমিস্টার পড়েছো? ও
এই সেমিস্টার।
ঠিক আছে, ঠিক আছে, উনি নিশ্চয়ই এগুলো বলবেন। ওকে ফাইন। হ্যাঁ, যেখান থেকে আসছিলাম, দ্যাট মিনস এইবার দেখো, আচ্ছা এটা একটু ছোট করি। ধরো এখানে সিগন্যাল আছে, এই সিগন্যালটা হচ্ছে আমার ভিআই, and that is given to this one. Okay, what is this network? কি ধরনের আরসি নেটওয়ার্ক এটা?
হাই পাস
হাই
ফিল্টার,
পাস না লো পাস?
হাই পাস ফিল্টার।
ফাইন, হ্যাঁ ফাইন। Now in this signal VI, what is the frequency during this over this period of time? Is there any state change at the output over this duration? Over this duration, is there any state change at the output?
No, sir.
No, it is continuously high. Similarly, over this duration, there is no state changes available at the output. So what you can assume that the input is almost DC. So during the clock, the VI high level and the VI low level, the input is basically, it may be considered to be on DC level. Having a DC frequency কত হয়? Infinite frequency, তাই তো DC?
Zero, no, sir.
0, sir.
So the DC, for DC, the frequency content is, frequency part is 0, absolutely 0. So what is ideally expected, that this network will block the DC part, because the, for the DC the omega value is 0. So the DC part will be totally blocked by this network. So that means that will not be available at the output. Sorry. What about here? Is there a state change at the output?
Yes, sir.
Yes, sir.
And what is the rate of change?
Infinite.
Almost infinite.
Almost infinite and plus infinite. So the frequency component for that part will be almost plus infinite value. Roughly, I can say it roughly. Actual thing will come if I go for the so that I am not doing here. What I am saying, that as the input is changing almost with infinite slope, I expect the input to possess almost a very, very large frequency there. What about the next falling edge?
Minus infinity rate of change.
Yeah, then the rate of change is minus infinite. So once again, there is also expected that the omega value is very, very large. So this VI, as if now I can say that during these durations, almost the VI is treated to be DC. That means the omega value is nearly 0. And during these portions, the omega value is very large. So as a result, as this network is nothing but one high pass filter network, this will pass these edges and block the DC levels. So at the output, there is expected response will be some sort of this. All the edges will be available. And what the books does is they gives a diode there. So after, due to the placement of this diode, what will happen is these negative peaks will be blocked and only the positive peaks will be enabled by the diode. So after the diode, what I'll be getting is this type of waveform. So here this also is basically extracting the edges or the rising edges of the clock signal. So in most of the books you will find that they are using these type of high pass filter diode combinations to extract the rising edges from the clock, and they are feeding this signal to the clock input of the Clk latch, and they are terming that composite structure to be one Clk flip flop or Esr flip flop. But that is also not being used in practical life. We never go for one edge extractor circuit for implementation of one flip flop. We never do that. This theoretically we can do it, but practically that can never be applied, because these durations, they are not fixed always, and as they are not precisely determined, I cannot predict whether this duration or this on period is sufficient or not. So we never go for this type of structure. So but why have you gone for this? We have faced one problem with the Clk latch, and that problem with the Clk latch is if I go for use of j is equal to 1, k is equal to 1 state. Now, and if the clock active duration is quite long, in that case the output will race around between the logic 1 state and the logic 0 state, and that problem is called the race around problem. Now, to avoid that, one very good solution is straight away to go for one Clk flip flop. But how to design one Clk flip flop, we do not know. So next we try to implement some sort of flip flop response type of thing by converting the long active duration clock signals to one very short active duration clock signals through the use of edge extractor circuit using the AND gate and inverter, or through the RC network, where the RC network is implemented in the form of one high pass filter. But both these two solutions of edge extractors are not very advisable. So next, what can you do? I've used two Esr latches. One Esr latch is being used as a master latch, and the second Esr latch is being used as one slave latch. And the active clock level for the master is the high level, and the active clock level of the slave is the low level. This is your clock signal. Fine. Now, how long QQM bar will have the states changed? How long QM and QM bar will change with respect to S and R?
As long as clock signal is active.
As long as clock is active. And what is that active state of the clock? High or low?
High.
So over this duration, QM bar will vary along with S and R. There's S and R will have direct effect on QM bar over the duration over which CLK is logic high. But during that duration, what happens to the slave clock? Is it active or inactive?
Inactive.
Inactive. So as a result, what happens to QQ1? Will they change with QM bar?
It won't change.
It will not change. QQ bar will not change. Though QM bar is changing their states, but QQ bar will definitely not change because it's the clock of the slave is inactive. So the slave output will maintain the previous slave output values. Hope it is clear.
Yes, sir.
Fine. Now next let me come to this duration over which clock is 0. So when the clock is 0, what happens to master?
It becomes inactive.
The QM bar will no longer vary with S and R because the master clock has become inactive. So what is the S and R value? What are the S and R values which have affected QM bar last? What are the final S and R values which have affected QM bar? Now the S and R values that were available just prior to the arrival of the clock falling edge. Just prior to the arrival of the clock falling edge, that means at this point of time, whatever S and R values were there, that had certain effect on QM bar, and that's the last S and R set of values which had affected the QM bar. After the arrival of the clock falling edge, even if S and R are changing their states, that will have absolutely no effect on QM bar. So, what are the last S and R values which are having effect on QM bar? Now, the set of S and R values which were available just prior to the falling edge of the clock. Is this point clear?
Yes, sir.
Fine. Now, over this duration, when the clock is 0, the slave clock is
Active.
So now QQ bar are free to change along with QM bar. But are QM bar changing over this whole duration?
No, sir.
No. The QM bar are no longer changing. What is the last status of QM bar? Now the status of the last QM bar dependent on the S and R values which were available just prior to the arrival of the clock falling edge. So in effect, this QM bar are sensitive to which S and R values? this final Q bar, these are dependent on which S and R values?
S and R values that are available just before the falling edge of the clock.
Yeah. So this Q bar is not dependent on the S and R value which was available here, nor the S and R values which are available here, nor the S and R values which are available here, nor the S and R values which are available here, but it is dependent on the S and R values which were available just prior to the arrival of the clock falling edge. So in essence, this is going to give you the response of one
Negative edge trigger.
this is क्या सुनते पेला ना राजदीप
Sir, negative edge trigger.
negative edge triggered what latch
Flip flop. Flip flop.
flip flop. So though we have used two latches in this master slave configuration, but this composite structure is going to give us the response of one negative edge sensitive flip flop. But I cannot term this as one flip flop. This is definitely not a flip flop, but this is one master slave latch which will give the response of one negative edge triggered flip flop. Flip flop a response there, but this is not one flip flop. This is one master slave latch, master slave Esr latch. Can I extend this master slave Esr latch concept to our JK latch so that we can avoid the resonance problem? Can I?
Yes, sir.
Because we had predicted that if I can go instead of one JK latch, if I can have the response of one JK flip flop, as the JK flip flop is S sensitive with respect to the clock, in that case I should not bother about the clock width or the clock active duration, over which many times the output will rest between the 0 and 1 values. So the rest error problem may be avoided if I go for one JK flip flop, or you can extend that to if I can have one JK flip flop response. Now let us go for that. So this once again instead of here instead of using the JK latch, I have used Esr latch. I have used JK latch. So expected that this should be the JK master slave configuration, but I'm still saying that expected, and it is expected that this may resolve the race around problem situation. Now let us see. Definitely this কোথায় গেল ঝামেলা করে না definitely this overall master slave structure as explained in the Esr master slave, this will definitely give the final output Q bar will depend on the JK value that was available at the falling edge of the clock, isn't it? Just like if I analyze it just like the previous Esr master slave, here also the Q bar will depend on the QM bar value that was available at the falling edge of the clock, and at the falling edge of the clock, the QM bar, that depends on the JK value that was available at that particular time instant. So overall QQ bar, that will depend on the J and K value which was available just prior to the arrival of the clock falling edge. That is fine. এটা কোনো ডাউট আছে? তাহলে আমি রিপিট করব, আমি এটা অ্যাজিউম করে নিয়েছি তোমার এসআরটা মনে রেখেছে তার জন্য। Is there any doubt?
No,
No,
sir.
sir.
Fine. But here the problem will be the constituent elements of this master slave configuration are the latches. The problem was with the JK11 value. Now when J and K are both 1, in that case, over this duration, what will happen to the master output? What will happen to the master output over this duration? Will it toggle only once?
Race around the
Yeah. So over this clock high duration, the output QM bar will race around between the 0 and 1 values. So output QM bar will go on toggling in many number of times. So I cannot avoid the race around problem here. So as I cannot avoid the race around problem here in the master slave itself, so I cannot predict what will be the QM bar value just prior to the arrival of the clock falling edge. So if the QM bars are going on toggling, in that, can you say definitely at the time at the arrival of the clock falling edge what will be the value of QM and QM bar? Can you say that? Can you predict that?
no,
No,
sir.
sir.
No, sir.
So once again, the final QQ bar, they depends on the available QM bar value at the falling edge of the clock. So as that QM bar value are not predictable, so the final QQ bar will also be not predictable. So JK master slave in this type of configuration cannot be allowed, cannot be used. So this will not eliminate the race around problem. So but the JK master slave has given me some very good insight that using the master slave configuration, I can synthesize, or I can get some sort of flip-flop action or some sort of age sensitive action. So somehow we are feeling that okay, if by some means that master slave thing could be used or can be used in JK also, that will be very good for us. That in that case, that will help us in resolving the race around problem instead of going for the flip-flop at all. Now, in the case of SR master slave, how many SR latches you have used?
2.
2. So আমরা সেই SR latch গুলোই রাখি, but not in the block form, but in terms of the individual gates. So আমি SR master slave-টাই রাখছি, but in terms of the gates, that is in terms of the internal circuits. So first I am going try to follow the way I am drawing. This is one SR latch, is it not? This is one SR latch. I am drawing, this is the slave, and now I am going for the master. How do you connect between the master and the slave? The master output goes to the master
Slave
output
input.
goes
Slave
to the.
input.
So this is your QM. This is your QM bar. Okay. And how the two clocks are related? The slave clock is 180 degree out of phase with respect to the master clock. So at an inverter থাকবে. Okay. Now, how do you convert one JK latch? Sorry, master. Sorry. How do you convert one Esr latch to one JK latch?
Cross feedback.
Cross feedback from the final output to the primary input. In the master slave configuration, where do you have the primary input? I have the primary input here, and the final output is here. You go for that cross feedback. Term this as J, this as K, this as Q, Q1. This is the master slave JK master slave configuration. I'll only analyze for the JK11 condition because other conditions for, are very straightforward. JK000110, those three conditions are very straightforward. I'm not going for the analyzing of them. I'll only go for the analysis of for the JK11 condition, where that race around problem is actually the problem which we are interested to solve. So have you followed the way I have drawn this structure? If you follow
Yes,
this, just first impression of this circuit is, oh, it is very complex circuit. But if you have followed the way I have drawn it, it will be a very simple one. Just start with the Esr master slave. That means one Esr slave, then one Esr master latches, then connect the master slave configuration mode. That means the master output should go to the slave input, and then go for the extra thing that is required for converting one Esr to JK. That is one final cross feedback from the final output to the primary input side. So that's what I have done. Fine. Now let me go for the 1-1 input combination. And definitely clock is 1. If clock is 1, you assume certain output values. Give me some output value. QQ1. Give me some value.
0, 1.
0, 1. So 0, 1 means this is 0, this is 1, this is 1, this is 0. Okay? This is the condition. And by the way, output is 0, 1. So QQ was 0, 1. That means my QM bar was also
0, 1.
So that 0 is available here. That 1 is available. Fine. Now I have the 0 to 1 transition of the clock. Oh. This is at the time instant my clock is 1. Okay, now what happens to this output?
0.
0.
What happens here?
1.
1. 1. Now what will happen to QM?
1.
1. What will happen to Q M bar?
0.
Okay. Now what will happen here?
Q will
What
be
you
1, Q bar will be 0.
No, Baba. What is the signal strength that is available here?
0. Clock is 0.
Clock is 1, so slave clock is 0. Is it not?
Yes,
Sarvesh?
sir.
Yes, sir.
So what about these two?
Maintained.
1, 1. So one S bar, the final slave S bar latch is having 1, 1 input pattern. So the slave output will be maintained. So output will remain 0, 1. Now here, now will QM bar have any more toggling effect? Will there be any more toggling effect at QM bar?
No, sir.
No, there will not be. So over this duration, let it be very long, does not matter. If JK is 1, 1, that 1, 1 is sensed here, and QM bar has toggled from 0 to 1 and QM bar from 1 to 0. And that QM bar state will be maintained. Now, when the falling edge of the clock comes, what happens to the slave clock?
Becomes 1.
Becomes active.
Becomes 1. So as that becomes 1, what happens to the slave? The slave is now active. But
Yes,
what
sir.
happens to the master clock?
Inactive.
Inactive.
So master clock is inactive. So QM bar will not have any other changing effect. QM bar will remain 1, 0. Now, as the slave has become active, the QQ bar of the slave will follow the slave input. That is the master output. So QQ bar will now change to 1, 0. This 0, this 1 will come here. This 0 will come here. But this clock has become 0. So though the slave output has toggled, and that toggling effect has propagated to the primary input side, but the primary clock has the master clock has already become inactive, so that will not go for toggling QM bar any further. So over this period, how many times the QQ bar is toggling?
Only 1.
Once.
Only 1. How many times QM bar is toggling?
Once.
How many times? Only once. QM bar is toggling where? At the rising edge of the clock. QQ bar is toggling where?
Falling edge.
At the falling edge of the clock. Okay. So if I follow this structure as the JK master slave structure, in that case, I can totally avoid the race around problem of the JK latch. I hope you have understood this one.
Yes,
Anybody
sir.
is having any doubt?
স্যার এই স্ট্রাকচারটা কি বলবো?
বলো
এই স্ট্রাকচারটাকে এটা তো মাস্টার
JK master slave. It is a JK master slave.
স্যার তাহলে
It is not your SR master slave. You have basically used the SR master slave, and then you have additional to the SR master slave, you have used one final cross feedback from the final output to the primary input. And in case of SR latch, if I go for one cross feedback from the final output, the primary input side, that gets converted into the one JK latch. So the SR master slave, when for that SR master slave, I go for one implementation of one cross feedback from the final output to the primary input side, that will get automatically converted into another master slave configuration, which should now be termed as the JK master slave configuration. SR এবং JK মধ্যে রিলেশনশিপ কি? SR latch থেকে JK latch কিভাবে যেতে পারি? By from the in the SR latch, if I implement another cross feedback from the final output to the primary input, that will be converted to another type of latch, and that latch is being termed as a JK latch. একইভাবে SR master slave আমি কনস্ট্রাক্ট ডিজাইন করেছি, সেই SR master slave এর যদি ফাইনাল আউটপুট থেকে if I go for implementation of one cross feedback to the primary input side, that will no longer be the SR master slave. So and that should now be termed as the JK master slave, because SR এবং JK কনভার্সনটা তো ওটাই হয়। SR এর তুমি ফাইনাল আউটপুট থেকে যদি প্রাইমারি ইনপুট ক্রস ফিডব্যাক করো, SR gets converted into the JK. ওকে?
Yes, sir.
আচ্ছা, আজকে আমি ভেরি কুইকলি আমি অ্যাটেন্ডেন্স নিয়ে নিই, কারণ আপনি ম্যামের ক্লাসে যেতে যাবেন না। মনসুর, মোহসিন মনসুর।
Yes, sir.
আশিস পাত্র, বৈভব,
Present, sir.
যোগেশ তিওয়ারি, অ্যাবসেন্ট। মুস্তাফা কামাল,
Present, sir.
সুবলিন সিং, অ্যাবসেন্ট। শিখা,
Present, sir.
সরোজ মোহন,
Present, sir.
Present, sir.
ব্রতিন ঘোষ, সন্দীপর্ণ,
Yes, sir. Present.
রিয়ন সামন্ত, অ্যাবসেন্ট। অঙ্কিত,
Present, sir.
সৌরভ সেন,
Present, sir.
সংগ্রাম সাহা। আচ্ছা, যাদের অ্যাটেন্ডেন্স দেওয়া হয়েছে তোমরা বেরিয়ে গিয়ে ম্যামের ক্লাসে ঢুকে যাও। সংগ্রাম সাহা, অ্যাবসেন্ট। সাগর চৌধুরী,
Present, sir. Present, sir.
বিপ্লব সরকার,
Present, sir.
মইনাক প্রেজেন্ট। আয়ুষ্মান ব্রহ্ম, অ্যাবসেন্ট। সংগ্রাম সাহা, ঠিক আছে। আচ্ছা, শুদ্ধ কি বোম্বে গেছে? তো ও কি কালকে পরীক্ষা দেবে তো?
ও তো বললো স্যার 29 ছাড়াও কোনোদিন প্রবলেম নেই।
আচ্ছা, ও কি মানে আরিয়ানকে জন্য বেলের জন্য গেছিল নাকি কে জানে? অনিকেত ঘোষ,
Yes, sir. Present, sir.
উদ্ভাস, সৌম্যজিৎ আচার্য, অ্যাবসেন্ট। অর্ণব শেঠ, অ্যাবসেন্ট। নীলার্ঘ রায়, অ্যাবসেন্ট। পারভেজ মল্লিক,
Present, sir.
আশরাফ হোসেন, অ্যাবসেন্ট। সৃঞ্জয় মন্ডল, অ্যাবসেন্ট। রশিদ আসগর, ডেফিনেটলি অ্যাবসেন্ট। আরিয়ান সর্দার, অ্যাবসেন্ট। অনিন্দিতা প্রেজেন্ট। পল্লব কুমার মন্ডল, অ্যাবসেন্ট। প্রসেনজিৎ মন্ডল,
Yes, sir.
প্রসেনজিৎ মন্ডল।
Yes, sir.
সোহম কাঞ্জি,
Present, sir. Present, sir.
শিল্পা মন্ডল।
Yes, sir, sir.
ঠিক আছে।
Yes, sir.
অনির্বাণ নস্কর,
Present, sir.
জয়দীপ প্রেজেন্ট। শুভজিৎ মন্ডল,
Present, sir.
মৃদুল সয়, অ্যাবসেন্ট। মৃত্যুঞ্জয় ওরাও, অ্যাবসেন্ট। সূর্য কুমার মাঝি, absent. Nishant Patel, absent. Gulshan Poddar,
Present, sir.
Obhirup Kobiraj, Ornik Chakraborty, absent. Orijit Paik, absent. Soumik Chaudhary,
Present, sir.
Rajdeep Kundu, present. Obhirup Saha,
Present, sir.
Shourjo Dotto,
Present, sir.
Sritama Ghosh, absent. Himanish Pal,
Present, sir.
Himangshu Ranjan, absent. Biplab Mahapatro, absent. Joyita Rai,
Present, sir.
Saptasya,
Present, sir.
Orpon Gayan, absent. Ovik Pal, present.
Present,
Tomal Khada,
sir.
Prosenjit
Present,
Jodipa,
Present, sir.
Nasiruddin, absent. Okay, thank you.